Hello everyone, let's take a look at our next problem. If a round table has n people sitting around it, what is the probability of person A sitting exactly k seats away from person B? Okay, sitting exactly k seats away. I think drawing a picture here is probably a good place to start. Some things we'll have to keep in mind are that because it's a circular table, in some sense there are two ways for this spacing to happen, right? Person A could be k seats away from person B on the left, or k seats away on the right. In fact, I think this is not difficult at all, now that I think about it. So let's draw what do I have here? I have seven seats. Isn't the answer just 2 out of n? I mean, I guess it'll depend. Okay, let's break some cases down. I see how some special things could go on here. So let me illustrate what I'm thinking here in terms of special cases. What we can do is we can always assume that person A is fixed at one point, and then we just have to think about where person B could possibly sit. So if k is equal to 1, there are 2 seats where person B could end up 1 seat away. If k is equal to 2, there are also 2 seats, and if k is equal to 3, there are also 2 seats. Now, that's kind of the fact that it's, for this picture, for this arrangement, where I have 7 people, if k is equal to 1, 2, or 3, the answer is going to be 2 and 6, because any of the 2 remaining 6 seats, well, so for k equals 1, there are 2 out of the remaining 6 seats which work. So the answer is going to be a third. Can we allow k to be greater than? So the question is not completely clear on exactly how to interpret some things here, but if in this example with n equals 7, if k is equal to 6, does this count because this is 6 seats away in the other direction? I'm not completely sure how to interpret that. What I'm going to do, because there's obviously, you know, if we do interpret it that way, then k equal 1 and k equal 6, the problems are equivalent. Now what's special is that here n is odd. There are 7 people. If there were an even number of people around the table, like this, then there's a special case where, I mean, if we just work through all the cases again, if k is equal to 1, the answer is 2 out of 5. If k is equal to 2, the answer is still 2 out of 5. But if k is equal to 3, the answer is only 1 out of 5. So we have to be careful whether n is even or odd. I think we can pretty much just break this down now. Okay, so let's start with odd n. The probability is going to be 2 divided by n minus 1. Right, so if there are 7 people around the table, it's going to be 2 out of 6 for any value of k. And if n is even, p will again be 2 divided by n minus 1 for k not equal to n over 2, and it'll be 1 over n minus 1 for k equal n over 2. I don't see anything different, anything special here, or anything that could break this. Again, you know, we should interpret k as always being less than or equal to n over 2. If k is greater than n over 2, then we're kind of going, it's the same problem, you're just going the other way around the circle. I think that's it. I don't see anything more that could sort of trip us up in this question. If I think of anything that I may have done incorrect or have more thoughts on this, check the description and I'll write my final thoughts. Otherwise, thanks for watching.